Lesson 4.8 is solving problems with trigonometry. So these are the real-world applications. These are the word problems, okay? And I know you don't necessarily want to hear that they are the word problems, but that's what they are. My opinion of these word problems, if you can get a picture drawn up and you know your trig relations like SOHCAHTOA, the majority of them are not too bad. Now, are there some tricky ones in there? Yes, I'm not going to argue. There are definitely some tricky ones in there we'll have to talk our way through. But the basic concept behind this is not too bad. Kind of like we saw one the other day, a couple days ago in the lesson.
Can we draw the stuff on there now?
I will. I'll get it in later.
Okay.
So I know we need to get that in there. But right now, just pull your quiz out beside you. Right? Pull your quiz out beside you. I just ran out of time to get the chart filled in this morning. Okay. A little bit of definition, because you will see a little bit of vocabulary here. Angle of elevation and angle of depression. Probably things you've heard. I think we used angle of elevation in the last word problem that we had. Angle of elevation, the angle through which the eye moves up from the horizontal to look at something above. So that's usually the horizontal being ground level. Angle of elevation is the angle between the ground and what I'm looking at up above. Okay, angle of elevation. Angle of depression, the angle through which the eye moves down from the horizontal to look at something below. That's more of I'm standing on top of a building and I'm looking at something ground level. So that is the difference of, like, if I look straight out, the difference in that angle to the angle of me looking down at a car on the ground or something. Okay? So, just good vocabulary to be familiar with. Let's look at example 1. The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of the water, is 6 degrees. Find the distance x from the base of the lighthouse to the buoy. Well, guess what? I'm going to draw. Picture time. Now, we have a lighthouse. Sorry, I don't get fancy here. There is my lighthouse. I can try to think what all I have on here, yeah. I mean, if you want me to get fancy here, I'll label it. Draw a fancy lighthouse if you want a fancy lighthouse. Okay, we've got this lighthouse. And we're talking about the distance from the base of the lighthouse to a buoy. So my buoy is going to be represented by this point over here. And what else do I have? The angle of depression of a buoy from the top of the Barnegat Bay Lighthouse, 130 feet above the surface of water. So that tells me the lighthouse is 130 feet tall. And the angle of depression is 6 degrees. Now, what that is saying, okay, if I'm standing on the top of that lighthouse, that dotted line represents me looking straight out. The angle of depression being 6 degrees, okay, that was not a very straight line, sorry. Pretend that is a straight line. I'm going to try and fix that a little bit better. Okay, there we go. 6 degrees is the difference in the horizontal looking out and the angle looking down at the buoy. And then it says find the distance x from the base of the lighthouse to the buoy. So we're finding x right there. Now, what did I end up drawing? A triangle, yes? Specifically what type of triangle? A right triangle, which is what you're going to see in these pictures, right? SOHCAHTOA works with right triangles. We're trying to find x. We know 30, or 130. We know the 90-degree angle. Now, okay guys, geometry time. There's a geometry rule that is going to help us know Well, there's a couple different ways we can do this, I guess. I need to know at least one of those angles inside the triangle. Jacob?
The horizontal at the top and the line must make a right angle.
Okay.
So you gotta do 9 minus 6 to get right angle.
Okay. So right here, the lighthouse and me looking out, that makes a right angle, that dotted line in the lighthouse. If 6 degrees is that angle of depression, 90 minus 6 is 84 degrees. So I guess that's not even geometry right there. That's just recognizing we see a right angle. What does that make this angle down by the buoy? What does it make it? 6 degrees. And for whatever reason, my mind looked right over the right angle for a moment. But do you remember a geometry rule? If 2 parallel lines are cut by a transversal, alternate interior angles are congruent. Does that ring any bells? Is that still how it's worded? Maybe a little. So the idea being the sea level here, so the distance from the lighthouse to the buoy, is parallel to that dotted line up top. Those are 2 parallel lines. The transversal is this hypotenuse of my triangle. And so 6 degrees up here is going to always be equivalent to 6 degrees down here. That's a geometry rule. I don't always remember all my geometry, but I remember that geometry for whatever reason. Okay? So that's another way. The right angle works perfectly well, too. Okay, guys. We need to find x. How would you like to find x? Think about your trig functions. Think about the fact I have to find x. I know 130. Next, we have angles we can pick from here. What are you going to go with, Jacob?
And do the tangent of 84.
Okay. And if we do the tangent of 84, what is that equal to?
So
Yeah, tangent is opposite over adjacent, so you could say the tangent of 84. 84 degrees, that is equal to x over 130. I'll be honest, that's not the one that I usually do. It makes sense, though. It's totally right. I usually, because they give me 6, I usually use the 6 down here. So another option that is equally correct is to say the tangent of 6 is equal to 130 over 6. Did I say 130 over x? Sorry. Tangent of 6 degrees is equal to 130 over x. Does it matter which of these you solve? Absolutely not. They both get you the same answer eventually. Just do it right. So here, if this is x divided by 130, we'll go ahead and use Jacob's here. Tangent of 84 equals x divided by 130. If it's x divided by 130, we need to multiply by 130. And so x is going to be 130 times the tangent of 84 degrees. I have my answer to 2 decimal places. The book does 1 or 2. I can't remember what. The book might do 1. What do you guys get when you plug that into the calculator? What do we get? Let's see if we all got the right answer. AKA, are we all in the right mode?
So for this one, you want to be in degrees, right?
Yes.
No.
I wasn't very
We want to be in degrees because they gave us degrees, yes? They gave us degrees, whether you did the 84 degrees or 6 degrees, they gave you degrees. So definitely need to be degrees. And in fact, most, if not all of today's homework, you're going to want to be in degrees. You got a 1,000 number?
1,036.867.
Okay. I have 0.87 written in my notes, so that would round. And that is 1,236 and 87 hundredths feet. Okay. Questions on that one? That's the basic type problem that get the picture drawn correctly, it's not hard to do. Okay? You're going to see some like that in homework. Those are doable. Okay? Draw the pictures to help you set it up. Example 2. From the top of the 100-foot tall Altgett Hall, a man observes a car moving toward a building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? Okay, well, you guys know how these math notes work, right? This is the next step up. This one does take a little figuring out, but let's work on getting a picture set up. So, I'm going to put my hall over here. I know my hall, my Altgett Hall, is 100 feet tall. I've got a man standing on the top of the building. And here's the deal. He's observing a car, and it's moving toward the building. So the idea here is that the car is starting way out here. And then he observes it moving this way. And now the car is there. Does that make sense, what I'm saying here? The angle of depression changes from 22 degrees to 46 degrees. So again, think about that angle going out. The first time he spies the car, the angle of depression is 22 degrees. So we're looking at this right here is 22 degrees. But then the car's moving towards him. And as the car moving towards him, that angle of depression increases to 46 degrees. So now we have from the horizontal here that is 46 degrees. Okay. How far does the car travel? So if we're asking how far the car travels, we're trying to find x right there. And that's where you have to think about we're going to have to do a little bit of work on this problem. Because we want this piece right here, which is not a full side of a right triangle. Does that make sense? It's pieces of a triangle, and it's pieces of a right triangle, but it's not a side of a right triangle. Now, obviously, I created a right triangle here, right? With the ground and the hall. If I look here at 22, if this angle up here is 22, what else is 22? The angle right out there? Yes? Okay. Because again, that's running along that transversal of where the car is first located. If this angle up here is 46, what else is 46? And that's going to be right here. And I'm not against the idea of, yes, this is a right angle up here also, right? And you can use that idea as well. I just think with the two triangles and a triangle, it was a little bit easier this way. So if you want to do the 90 minus 22, 90 minus 46, and find your angles that way, that works too. Just keep it all straight. Okay. Do you see where we're headed here? What are you thinking?
We're going to have to find values for each of the triangles and then subtract the difference.
Yep. Okay. Basically, we're going to have to find the bottom length of each of these triangles. We're going to have to find the distance the car ended up here from the hall, which I'm going to call D. So the distance of that triangle that has the 46-degree angle. And, do I have room to write it in here? We're going to have to find the whole distance, which I think is Y in my notes. And then once we know Y and once we know D, we can subtract to get X. Okay, so as I said, this is the step-up problem. You won't see nearly as many of these in homework, but you will see a little bit. So, as we start to set up here, what can I set up? How can I find Y? Y is the length of the entire bottom side. So we're going to have to use the 22-degree angle and say what? We know 100 over here, and what am I trying to find? Trying to find Y. And again, realize there's more ways you could do this, but this is one. But one option is I can say the tangent of 22 degrees is equal to 100 over Y. And we can find that, right? If it's 100 divided by Y, I'm going to multiply by Y. So Y times the tangent of 22 degrees is going to equal 100. And then to get Y by itself, I'm going to divide. So Y is going to be 100 divided by tangent of 22 degrees. You get an answer for that. Did you get an answer? Honestly, I would just leave it in your calculator. I mean, I'm going to write it down here. Did you get 247 something? Okay. Don't round it too much. Okay, if you want to go ahead and round it some, leave at least an extra decimal place for when we subtract and round it at the end. Honestly, easiest thing to do is just leave it in your calculator and go up and copy it later. Now, so we found Y. What can I find next? I can find D here, because that's the bottom leg of the 46-degree angle. So I can say the tangent of 46 degrees is opposite over adjacent, so 100 over D. Do the math. If it's 100 times d, or excuse me, divided by d, I'm going to multiply d. So d times tangent of 46 degrees equals 100. I'm going to divide by tangent. And so d is 100 divided by tangent of 46 degrees. And again, d is some decimal, right? (96.5688), so on and so forth. And how do I finish this off? Subtract, right? Officially, in order to find x, it's y minus d. Again, this is where I just would arrow up, copy at my calculator, minus, arrow up, copy at my calculator. 247 something minus 96 something. I have 150.94. That's going to be 150. Excuse me. Thank you. 150.94 feet. Yeah, you're going to see a few of those guys. You're going to have to try them. I know that's the hard type, but draw that picture, get set up, see what you can do with it. I know you're hoping for more like example 1 than example 2, but okay, guys. One last question I want to talk about. Hello. Yes. Okay. Okay. Valid point. Okay. Thanks. Bye. Okay, example 3. No fancy word problem. Just a picture for taking, we need to work on this basic concept here. Our goal is to find theta. We know sides of 62 and 56, and we need to find theta. What's the relationship between the 62, the 25, and the theta? What relates those three pieces together? Tangent, yes? It's a tangent day. What can I say? So what am I going to write here? The tangent of theta is equal to 25 over 62. Can you agree with me on that one? Now the question is, how do I solve? How do I find theta?
Bringing in tangent inverse.
What allows us to switch our x and y values? To switch our input and input and output. Tangent inverse. Okay, we're trying to find an angle. What is tangent? What do any of the inverses give me? Their answers are angles. So this is a really good one to think about. This is technically based on what we did do yesterday. So tangent inverse, in other words, in order to find theta, and actually I should write this the other way, but tangent inverse of 25 over 62 is going to be equal to theta. So if you're given tangent and you're asked to find some angle, and it's not an obvious one you know, tangent inverse. Now, what mode do you want to be in? Well, what kind of answer do you want out? Do you want a radians answer or a degree answer? And that just depends on the setting. In this situation, a degree answer makes sense to me, because if they give me radians, I'm going to get some decimal that doesn't really mean a whole lot to me. If they give me a degree answer, that's going to mean something to me, isn't it? So what are you guys getting? Well, first of all, remember, tangent inverse, you do use your second tangent function. What do you got? What's the calculator telling you if you're in degrees?
1.96.
Yep. 21.96 degrees. Okay. I'm not sure how much that pops up in homework, but that's a concept we've got to work on there. Okay. Homework that goes with this lesson is page 393. 1 through 16, 19 through 24. That is due tomorrow or whenever we're next in class. Which, I agree with Connor. I feel like we could very easily be here tomorrow. So, if we're not, it'll be due on Tuesday because there's no school Monday. I'm also going to hand out the review worksheet. The review worksheet is, don't get started on it. It is what I will hand out tomorrow for assuming we're here. But if we're not here, you can guess what I'm going to put up as e-learning tomorrow. Okay?